We're continuing with our Math 1111 final exam review. We're on page 8, the final page, and we're under the heading Exponential Equations. And the first question asks us to solve the equation 2 raised to the 7x minus 5 power equals 8 raised to the 5x plus 9 power. Now, there's a variety of methods for solving exponential equations. The easiest method is to rewrite it so that you have the same base on either side. If I have a base 2 on the left and a base 2 on the right, which I don't, but if I did, I could simply set the exponents equal. So I want to think about, could I rewrite maybe 8 as a base 2? You may or may not recall that right off the bat, but 8 happens to be 2 times 2 times 2, or 2 to the third power. So I actually can rewrite this where I have the same base. So I would have 2 to the 7x minus 5 equals 2 to the third. I'm going to replace 8 with 2 to the third raised to the 5x plus 9 power. Now, in doing that, what you have to remember then is you have that power to a power rule, which says you're going to multiply those things together. So we have 2 to the 7x minus 5 equals 2. And then we do 3 times 5x is 15x. 3 times 9 is 27. So we have an exponent of 15x plus 27. Then, because we have a base 2 on the right and a base 2 on the left, the property says if you have a to the m equal a to the n, then m is equal to n. The exponents are equal to one another. So in this case, we would have 7x minus 5 equals 15x plus 27. And that's just a good old basic algebra equation that I need to solve for x. So I'm going to subtract 7x from either side so that I can get all the x's together. So I have negative 5 equals 8x plus 27. Then I'm going to subtract 27 from either side, again, to get the x by itself. So I have negative 32 equals 8x. I'm then going to divide both sides by 8. Again, trying to isolate the x. So negative 4 equals x. There's my solution. All right, looking at the next one, solve the equation, or solve for x in the equation 7 to the 3x plus 6 equals 4 to the 5 minus x. Now this one's not near as nice because 7 and 4 are definitely not the same number, so I don't have the same base. I can't write 7 in terms of 4, nor can I write 4 in terms of 7. So we're going to have to use the fact that logarithms are the inverses of each other. Exponentials and logarithms are inverses. So we're going to do the natural log, since I don't have a common base. I'm going to use the natural log of 7 to the 3x plus 6 equals the natural log of 4 to the 5 minus x. I'm going to take the natural log of both sides. Then I'm going to apply my logarithmic property about the exponent. So it's going to become exponent 3x plus 6 times the natural log of 7 equals exponent 5 minus x times the natural log of 4. I'm going to use the distributive property so that I have 3x times the natural log of 7 plus 6 times the natural log of 7 equals 5 natural log 4 minus x natural log 4. And then I noticed that I have pieces that involve x's on both sides and pieces that involve just numbers on both sides. So I need to get those together. So I'm going to add x natural log 4 to either side so that I have 3x natural log 7 plus 1x natural log 4 plus 6 natural log 7 equals 5 natural log 4. Then I'm going to subtract 6 natural log 7, which is a constant, so that I have isolated the pieces that involve x. So I have 3x natural log 7 plus 1x natural log 4 equals 5 natural log 4 minus 6 natural log 7. And then I notice that my denominator, or excuse me, the left side, both pieces have this common factor of x. So I'm going to factor that out. So I have x, and I have 3 natural log 7 plus natural log 4 equals 5 natural log 4 minus 6 natural log 7. So basically, the piece within the parentheses and the piece on the right, they're going to be just numbers if I plug them into the calculator. So to solve for x, I need to divide both sides by the 3 ln 7 plus ln 4. So we end up with x equals 5 times the natural log of 4 minus 6 natural log 7, all divided by 3 natural log 7 plus natural log 4. Now, if you want to get a decimal approximation, we definitely want to pull out our calculator. So if I put this in my calculator, okay, we're going to put parentheses around the top. So we would have 5 natural log 4, close that parenthesis, minus 6 natural log 7, close the parentheses on the top, divide, open the parentheses for the bottom, 3 ln of 7, close the parentheses, plus ln of 4, close the parentheses on the bottom. We hit enter, and we get approximately negative 6.57. Okay, so decimal-wise, this is approximately negative 0.657. All right, then we get into logarithmic equations and trying to solve those. And again, there are a variety of methods for doing that. Again, I like to use the idea that logarithms and exponentials are inverses of each other as long as you have the same base. So in this first problem, I have a log base 8. So I'm going to do 8 raised to the log base 8 of x to the third equals 8 to the second power. And again, the benefit of that is remember that an exponential base 8 and a logarithmic base 8 will divide out or cancel. So we have x cubed equals 8 squared, which happens to be 64. And then I need to undo the cube, so I'm going to take the cube root of both sides. And you could get your calculator out if you want to do the cube root. Okay, to do the cube root, we press math, we choose option 4, put in 64, and enter, which gives me a value of 4. Now, you might be able to do that one in your head because you're trying to figure out what number did you multiply times itself 3 times to get 64. So our answer is 4. Then we have log base 3 of x. That should be x plus 14, not equal. So let me put the plus sign in there. Minus log base 3 of x equals 2. Okay, so this one we have two logs that are being subtracted, so we want to use the property of logarithms to put it together, and when we do that, subtraction becomes division, so we have x plus 14 over x, which equals 2. Then I'm going to use the property that exponentials and logarithms are inverses. So I'd have 3 raised to the log base 3 of x plus 14 over x equals 3 squared. Again, the benefit of that is that log base 3 and exponential base 3 will divide out. We have x plus 14 over x equals 3 squared, which is 9. I'm going to turn it into a fraction by putting it over 1 so that I have basically a fraction equal to a fraction, and we're going to cross multiply. So when I cross multiply, I have 1 times x plus 14 equals 9 times x. So I have x plus 14 equals 9x, and I'm trying to solve for x. So subtract x from either side. So I have 14 equals 8x. I'm going to divide both sides by 8. So I have x equals 14/8, which simplifies to 7/4. So my answer would be 7/4. Okay, and then we're going to get into looking at the applications of exponentials and logarithmics in the last and final video.